How are you, everybody who is watching this fantastic video? I would like to take this opportunity to welcome you into the program of learning calculus or engineering mathematics. My name is Olenjolai. I'm very happy to have you today. And I'm here actually to teach you some few concepts about Fourier series, and especially the second subtopic or second topic that called Fourier series for the non-periodic function. Remember that always I want to tell you, and I will keep on telling you, that I don't know everything about mathematics. I love mathematics, but I'm here to teach you some few concepts that I know, and I have a responsibility to teach you. In case you have any question, don't hesitate to ask it, but I'll try my level best to answer a number of questions going on through your mind. So this is the modus calculus or engineering mathematics, and this is for the bachelor or for the undergraduate level. And the topic, this is chapter 5. For the sequence of the calculus is chapter 5, that's called the Fourier series. Okay? So today we are in lecture 8. We are in lecture 8. So in this lecture 8, we'll be focusing about problem solving of what? Of Fourier series, problem solving of Fourier series of so write this title, non-periodic function. Non-periodic function. So that's the concept that we are going to learn today. We have already covered almost 7 lectures. So this is lecture number 8 from the beginnings of the Fourier series. If you missed the previous contents, you have to check onto in our channel. Then you refer the previous lecture, which is lecture 1 or lecture 0 to lecture 7. So when you say non-periodic function, this is the function which disobey the conditions of what, students? Periodicity. So before we go into the problem solving, let me just remind you some few concepts that we covered. This is called a quick review of lecture 7. So the first concept that I told you in that lecture is this. We said we have something we call the condition of what, class. I have some local students. Good evening, local student. Good evening. We didn't hear you. Good evening. Hey, Richard. Good evening, Richard. Hey. Good evening, all of you. Good evening. Good. So condition of what? Periodicity. And these conditions of periodicity is simply that we say that f of x plus period, this should be equal to f of x. Or this one is equal to f of x plus pi. Sometimes we say that it is 2 pi, because 2 pi is a period. So it means that the value of the function should be equal to the value of the function plus the period. So this is the conditions of what? Periodicity. So you say that a non-periodic function, disobey what? Disobey the conditions of what? Of periodicity. What does it mean? It means that for the non-periodic function, f of x is not equal to f of x plus period t. Okay? Then I gave you some examples of these, examples of what? Examples of non-periodic function. We say that if you've been given f of x is equal to x, let's say f of x is equal to x squared, or let's say that is equal to x cubic plus 4, or maybe it can be what? Actually that f of x, let's say is equal to e power x, or let's say that f of x is equal to ln of x. So we have a number of examples of this non-periodic function. But again, we say that Mr. Fourier actually that introduced the concept that Fourier introduced a concept that we say that if we extend what? The graph of what? If you extend the graph of non-periodic function, right, outside of 40, of the given range, then that function, then that non-periodic function will be what? Will be periodic function. So we discussed that, and we use the graph to illustrate or to explain the concept. So it means that a non-periodic function can be transformed, or it can be converted, or can be changed into the periodic function if the graph has been extended outside of the given range. So it means that on the left-hand side and the right-hand side. And the graphs we extend by using the dotted lines. So the given function and the given interval will give us the image of the extended function, so extended graphs of a function. So from there, it means the non-periodic function become what? Periodic function. So if that's the case, we can find all the three Fourier coefficients. We can find A naught, because I told you three Fourier coefficients. We can find A naught, we can find AN, we can find what? BN. But also, if that's the case, we can also find the Fourier series, which is f of x is equal to what? A naught plus what? Summation from n is equal to 1 to what? Infinity, open the bracket, an cos of what? Nx plus what? Bn sine of what? Nx. Then you close what? The bracket. Are we together? But another thing that, which I've introduced it to you in this concept, sometimes if the function, because in most cases, the function might be either polynomial function or exponential function or trigonometrical function. So in case of finding the Fourier coefficient of an and bn, you will always encounter the concepts of product, integrating the products of the two different functions. So for that case, you have to use the technique of what? Integration by parts. Are we together? It's a little bit different from the concepts of the Fourier series of the periodic function. Because in most cases, for those periodic functions, you'll find the function, okay, you can also encounter the concepts of integration by part. But sometimes you can find that the function is a constant. Maybe f of x is equal to, let's say, 5, where from negative pi to 0. And then the other one, f of x is equal to 0, you can find either it is a composite function. Okay? But in case of non-periodic function, when you are dealing with a Fourier series of non-periodic function, in most cases, you will encounter what? The product of two, or integrating the product of two different functions. Are we together? And the test two, they are the separate. For the first equation, for the second question. Okay? Fine. So if that's the case, let me teach you another example. And this will make example 1. Faraj, is this example 9 or 8? Example 9. Faraja forgot the number of the examples. So given that f of x, it's a composite function. Example 10. Yes, because I remember one of the examples, it was drawing the graph. So example 10. So given f of x is equal to x, when what? When 0 is less than x less than pi. And also when f of x is equal to 0, when pi is less than x less than what? 2 pi. So the question now, Roman 1, sketch the graph of f of x. Roman 2, obtain a Fourier series. Obtain a Fourier series for f of x. Obtain Fourier series for what? F of x. So that's the question. Because I told you that whether it is a Fourier series of non-periodic function or periodic function, or Fourier series of of odd or even function, or maybe of a half range of Fourier series, or Fourier series of any range, or of any, yes, of any range, or whether it's exponential or exponential or complex Fourier series. So it might be the function might be a single function or a composite function. So in example 9, I taught you how you can solve a Fourier series of non-periodic function where the function is a single function. So then this example, the main objective to show you that sometimes you can find a composite function of 2 subfunctions or 3 subfunctions. Are we together? So here it's a problem, then you have to solve it. I think you have copied this. So stop writing, just follow along. Solution. Okay, so this is the composite function. Say composite function. So why do we call composite function? Because this it is a composite function which actually consists of 2 functions. This is the first function and this is the second function. Right? So this is the subfunction and this subfunction, but the entire function is ffx. So that's why we call it a composite function. But you can find that this one is limited from 0 to pi, and this one is limited from pi to 2 pi. So don't ignore 0. 0 has also its contribution. Are we together? Huh? So if that's the case, so we go for the first step. The first step, we have been asked to what? To sketch. Sketch what? To sketch the graph. The graph of what? Of ffx. So here is the sketch. I said stop writing, want to sketch, listen, and watch. So this is y-axis, and this is x-axis. This is x-axis. So here it's 0. Okay? Then this one, here is pi. Here it's 2 pi. Then on the left-hand side, this is the point we have negative pi, and this is the point we have negative 2 pi. Are we together? Huh? So if that's the case, we have the function there. So this is the point where we have pi, and this is the point where we have 2 pi. Again, this is the point where we have negative pi, and this is the point we have what? Negative 2 pi. Why did I? Because you should not claim. Later on, we'll be dealing with Fourier series over any range, where the x intervals or the time intervals will not be in terms of pi, will be in the normal numerical values. So you should not claim that always the graph should consist of the pi. No. This is according to the question that you've been given. Are we together? So before you sketch your graph, you have to examine and analyze the given function. Okay? Okay? Okay. So if that's the case, then let us sketch the graph for the first subfunction. When x is equal to 0, where is 0? So here. When x is equal to 0, what's about y? Simple. So how can you know y? So you know that, So let us take, let's say ff(x1) is equal to x. So we have to find when we are finding when x is equal to 0, what is y? So y will be also 0. Okay? So it means that this is the first coordinate, or this is the first point. Okay? Then next, when x is equal to pi, so f2, when x is equal to pi, so this one is equal to pi. So when the value of x is pi, the value of y is also pi. So this is the coordinate. Okay? So from there, there's no need for you to go and sketch for the second function. You can sketch on this function because this is the independent function. Okay? So how can you sketch it? You just join the first point with the second point. Okay? Okay? But this is still what? It's still the half cycle. Then we go for the second function. The second function, this is, let's say, f2, let's say of x is equal to 0. Okay? Okay? So what are the intervals? When x is equal to 0, when x is equal to 0, so the value of y is still 0. So when x is equal to 0, no, excuse me, when x is equal to pi, because the function, the second function is constant, is 0, right? When the value of x is pi, the value of y is 0. So where the value of x is equal to pi? This one. But the value of y is what? Is 0. Where is it? So this is the 30 point. So if that's the case, it means that we say, okay, fine. So we draw the graph, or we join this point with this point. Because now I'm at this point. Okay? Then we go for the next one. ff2, when x is equal to 2 pi. So what the value of y? Still 0. Okay? So the value of x is 2 pi, but the value of y is 0. So I have another straight line here. Are we together? Class, are we together? Yes. So the graph is from here to here to here to here. But this graph, because the function itself is non-periodic, it will never repeat itself. Okay? So if it won't repeat, we have to extend this graph outside the boundary. So it means that. So then it means that if that's the case, we say that here we'll have 3 pi. But for you, maybe you can extend even the graph. I think that, okay, let's extend for you to understand. So this is 3 pi. Let's say this is 4 pi. Okay. I didn't say draw. I say listen and watch. Listen and watch. So now we want to extend the graph outside of the given range. This is the given range. So if we'll be asked to find the period is 2 pi. I will show you soon how we find. Maybe if you've been asked to find the period, this is the extra concept. The question did not ask us. So how can you find the period? Simple. You take the maximum interval minus the minimum interval. So the period is 2 pi. Okay? Okay. So then we want to extend the graph. So this is the point. Okay? So the way we extend, remember that this was the starting point. This is the starting point. Remember, this is no longer a cycle. It's a triangular. But it's not even an actual triangular. It means it's a triangular, but it's a kind of, it's a triangular and a path. If you want to describe the meaning. So this is the triangular, this is the path. Okay? So listen. So how do we extend? So this is our new starting point. We are going to make another complete, another complete what? Another complete oscillation. So how? So from here to here, it is 0 pi. So 2 pi to 3 pi, the distance is pi. So you say, okay, fine. So this is the extension of the graph. So where are we? Where are we? We are at this point. Then we have to go to move down. Then here we are going to have a dotted line. Then when you reach at this point, then again we have another dotted line. Are we together? Are we together? So again we extend the graph on this side. So on this side we have negative pi. Okay, fine. So okay, so from here to there, we say that here we are going to have what? Dotted line. At this point. Okay? Then if that's the case, then we this is the point. This is another one, negative 2 pi. So here we are going to have what? Another dotted line. So this dotted line will be descending at this point. Are we together? Are we together? So you can even extend again, okay? So this is the point, you are at this point, then you go for negative 3 pi. Then you move up, you go for negative 4 pi. So this is what? So This is, I think, that figure 3. Figure 3. Okay, figure 3, we say that the graph of, so the graph of what? Of f of x. So this is the graph. And this is all about what? The sketch of the graph. So now with this graph, then we can apply the concepts of Fourier series to find the Fourier coefficients and finally find what? The Fourier series. But if we have only the graph that starts from x is equal to 0 to 2 pi, then we cannot apply the concept of Fourier, because the condition for the Fourier series, we say the function must be periodic. So if it's not periodic, we have to make it periodic first. Are we together? Is it clear? Any question? Fine. Second step, keep listening. So the second step, we say that let us find what? Find Fourier coefficient. So we have to go. So find Fourier coefficient, and this Fourier coefficient, we call TA0. So to find, you have to recall the fundamental formulas that I have taught you. Listen, I taught you that you can find A0 by using either of the two formulas. But the one that I taught you, we say that 1 over 2 pi. Integral from negative pi to what? To pi. Then here we have what? F of x dx. Or you can use that. A0 is equal to 1. I say that, stop writing. A0 is equal to 1 over pi. Integral from negative pi to pi f of x dx. But in the general formula of Fourier series, you have to include A0 over 2. Are we together? Are we together? So you should not be confused, but you have to be careful. Because if you use these formulas, there's no need in the Fourier series, in the general Fourier series, to divide A0 to its 2. Because you have already divided. That's the meaning of these 2. Are we together? Okay. So if that's the case, listen. A0 is equal to what? 1 over what? 2 pi. So then, remember that these limits are general for the general formula. The limits always will be given in the question. Jacksoni. Okay. So this is our function. So we say what? We integrate. So we have composite function. So f of x, for this case, it's x. Then what? We say that dx. From where? From 0 to pi. From 0 to pi. Then plus. Why should we include plus? Because it's the composite function. Okay? Plus what? Plus integral. What the function? 0. dx. And the interval from what? From pi to what? 2 pi. Then we close the curly bracket. Are we together? Then here we are. So it means, okay, you know that the integral of 0 dx from pi to 2 pi is 0. It does not have any contribution, but you have to write it to illustrate that you have included, because even the graph, you see that how this function has affected the graph. Because without this function, you could not have this nature of the graph. Richard, you are not in the class. A0 is equal to what? 1 over 2 pi. Integral from what? From 0 to pi. Of what? X dx. Are we together? So if that's the case, third step, we have to recall. Recall what? How do we integrate? So the Fourier series has finished, or the concept of Fourier series has done its way. It's all about integration. So then we have to recall that integral of x power n dx. So this is equal to what? X power n plus 1 over n plus what? Plus 1. So because the quick review, there's no need for you to note anything. So let me clean there. Then you'll have some spare time for you to. So we say that if you're integrating from a to b, x power n dx, this is equal to what? X power n plus 1 over n plus 1 from what? A to b. For that case, we can find what? A0 is equal to 1 over 2 pi, Faraja is writing, from 0 to pi, then x dx, but the exponent here is 1, right? Huh? So if that's the case, we say what? If we integrate x to power 1, so we use this formula. The value of n is what? Is 1. So if that's the case, we have what? X. What the value of n? 1. Plus what? 1. Over what? 1. Plus what? 1. Limits from what? 0 to what? To pi. No need for you to claim. Then this is a naught. A naught is equal to what? Is equal to x squared over 2. Then the limits from what? 0 to what? To pi. Okay? So, but 1 over 2, it is constant. So you can take it out of the integral. Then you have what? X squared. From 0 to what? To pi. Then here it is. A naught is equal to what? A half. And then what? Pi. Pi square minus what? 0 square. The answer is equal to what? Pi square over what? 2 pi. The answer is what? Pi over 2. Okay? So the value of the first Fourier coefficient is pi over 2. Okay? So then, did you finish for this part? Can I clean here? Answer the question. Only here. I just leave the graph. Huh? Oh. Only the top part. So write quickly, 1 minute. Okay, so let us continue. I think that I made a mistake here. I made a mistake here. So let us correct the mistake that I've done. Because after we had 1 over 2 pi. So at this point, I forgot it. 1 over 2 pi. 1 over 2 pi. At this point also, I forgot 1 over 2 pi. At this point, so I have a half. So simply I can say times 1 over 2 pi. Then at this point, I still have, so I will have 2 times 2, I will have 1 over 4 pi. So this one will be 1 over pi square over 4 pi. Okay? So if you simplify, means you divide by pi, you have pi over 4. So a naught is not a pi over 2, it's pi over 4. And there's no need for you to underline, because the question asks us to obtain Fourier series. So the final response is Fourier series. It's not a naught, it's not a n, it's not a bn. Okay? Because you know that as adult students, sometimes you say, let it underline. So let the underlines as kind of the final response. No. So then we go for the first step. Okay? Okay, students? First step. So the first step, let us find straightforward the second Fourier coefficient, which is an. So to find it, we have to recall. To recall what? To recall the formula. The formula of what? The formula of an. So here we have an is equal to what? 1 over what? Over pi. Integral from negative pi to pi. Then we have f of x, then we have cosine of nx dx. Don't claim, because in the next topics, we'll change the angle of this cosine. In some cases, you'll find that we can have cosine of n pi x over L. So don't claim. Okay? So this is the general formula of the general formula that helps us to find the second Fourier coefficient, which is an. Separating, watch. So if that's the case, we have to remember the function which have been given. So an is equal to 1 over pi. Okay? Then we open the curly bracket. Then here it is. Okay? We integrate from what? We integrate from 0 to pi. You have forgotten. f of x is what? Is x. Then what? Cosine of nx dx plus integral from what? Pi to 2 pi. What the f of x? 0. 0 times what? Cosine of nx dx. Then you close the curly bracket. Richard, you're not listening, you're not watching. So if that's the case, then we say fine. So you can keep on simplifying. So we have an is equal to 1 over pi. Then we have what? Integral from 0 to what? To pi. Then you have what? X. Cosine of any x dx. Are we together? Then plus what? Plus 0. Because 0 times cosine of an x dx is 0. Integral of 0, it is still 0. Are we together? Are we together? Lazy students, they use always to skip this process, this step, and come to this step. But those are the lazy students. How much does it cost you to write this? We are going for the final exam, where actually you'll have a booklet of a number of pages. Even if you want to write 4 booklets, it's acceptable within 3 hours. Okay? Are we together? So if that's the case, we say that, okay, so let us call this as the question 1. So we go for the 5th step. Then we are done with Fourier. Now we are going back for the integration technique. Right? So according to the integration technique, here we have a product. The integrand, it's a product of the 2 different functions. Polynomial function, trigonometric function. Remember that I told you that the function, it might be polynomial, it might be exponential, it might be trigonometric function. It might be logarithmic. We have a possible, it might be the inverse, but in most cases, 4 possible functions. Either polynomial, right? Or exponential, or trigonometric function, or what? Logarithmic function. Okay? Are we together? Yes. So don't claim your mind that I always polynomial. No, no, no. That's not true. For instance, in test 2, we encountered a trigonometric function. It was very interesting. Okay. So the 5th step, we say that, let us go to, say that integrate equation 1 by using the technique called integration, what? Integration by parts. And this is the informal formula of integration by part. There is a formal formula of integration by part, but this is informal. We are trying to teach for engineers and scientists who actually they don't like it to think a lot and reason a lot in mathematics. So this is informal. That's why we say that if you integrate from A to B, U dv, this is informal. We have to say that, for example, the form 1, we say that integral from A to B of U of x, then derivative of v with respect to x. Okay, so this is simple. However, that in most cases, whenever it is students, they see that it is difficult. Okay, so then if we integrate this one, so this is dv, then you have u over v, then limits from a to b, minus integral from a to b, then we have v du. So for the formal, let's say, just let me give you the formula. So for the formula of integration by part that are acceptable in pure mathematics, we say that we are integrating u of x. Then we say that we have derivative, or we have derivative of v of x with respect to dx. This is equal to u of x multiplied by v of x. Okay, from a to b minus integral from a to b. Then we have v of x. Then the u of x with respect to x. So for adult students, this is simple rather than this. For advanced secondary students, we introduce them this formula for the first time. But this mathematically is wrong. Or it's not, this is not a mathematical formula. Actually, it is a mathematical formula, but it's missing some information. Okay? So from today, change your mindset to say, integration by part, the formula is difficult. Well, between this formula and this one, which one is difficult for you to remember? Okay. So if that's the case, then we are going, we have to compare. So listen, so he said that, okay, so you have to compare. So you have to compare, this is a, so let's say this is equation 2. So you have to compare. You have to compare what? The left-hand side of equation 2 and the right-hand side of equation 1. Faraja, I see that you are in your moment of Faraja. So compare. So compare what? Compare right or left-hand side of equation 2 and the right-hand side of equation 1. So to compare, so what do you say? Say that we integrate u dv from a to b. So you can compare with what? Integral from 0 to pi of what? Of xc, then cosine of what? Cosine of nxc dx. So if you compare, it's just like we say that let u is equal to x and let dv is equal to what? Is equal to cosine nxc dx. Are we together? Then if that's the case, we need, so u is equal to x. On right hand side, we'll have u. But we miss what? V. On right hand side also, we need to have du, derivative of u with respect to x. So you have to differentiate this function. Are we together? So we say that what? Du dx is equal to what? 1. There's no need for you to claim this is stuff. Du is equal to dx. So then we say what? We have dv is equal to cosine of nx dx. So to get the value of f, because on the left hand side you have derivative and right hand side you have derivative, you have to integrate. So you have to integrate left hand side, you have to integrate right hand side. We did not change anything because we applied the integration sign on the both sides. Simply, as adult student, I told you that this d will cancel this one. So simply, on left hand side, you have v. As adult, but there's a reason how d and this integral sign cancel. But it's not meaningful for you. Okay? Then, so we are integrating cosine of nx. I have told you, whenever that you're integrating cosine of x with respect to x, the answer or the response is what? Sine of x. But because we're integrating cosine of nx dx, so the response will be sine of nx over n. Why n? Because n is the coefficient of the angle. Are we together? So simply, according to the formula or the equation 2, we need this information. We need this equation. We need this equation. But I told you that don't do this in exam. So those are the three pieces of information we need to fill on the right-hand side. Are we together? So for that case, we say that we have been looking for a of n, which is 1 over pi. Then we say what? Integral of 40 from 0 to pi of x cosine of nx dx. So this is equal to what? Ladies and gentlemen, is equal to u. What is u? X. So let's say is equal to 1 over pi. Then curly bracket. What is u? X. What is v? Sine of nx over what? Over n. From what? From 0 to pi. Minus what? Faraja? Faraja is not there. Integral from 0 to what? To pi. I have 40 of sine of nx over n dx. Then we close the curly bracket. Okay. Then we have what? an. So an is what? 1 over pi. So we open the curly bracket. So n is common, so you can take it out. N is common. Are we together? Next, we substitute the upper limit. Here we have 40 pi. Sine of 40 n pi. minus what? 0 times what? Sine of 0 times n minus. If you integrate sine of nx dx, you get negative sine. If you integrate positive sine of nx, you get what? Negative cosine of nx over n. So that for that case, means negative times negative is equal to simply have positive. Positive of what? Of cosine of nx over n. From what? From 0. We have n outside here. 0 to what? 0 to pi. Then we close the curly bracket. Are we together? Are we together? So let me finish here. Then I will give time to write. Give you time to write down. Give you 1 minute to write down. Okay? So let us continue. So what is AN? But Faraja is always writing. AN is equal to what? 1 over pi n. Okay? Then we have what? Pi sine of n pi. N what? N pi. Minus what? 0. Then plus what? So substitute the limit. We have cosine of what? N pi over n. Okay? Minus what? Cosine of n times 0, which is cos of 0 over n. Are we together? Eh? Okay. So if that's the case, then we come. AN is equal to what? 1 over what? Pi n. Then you open the curly bracket. So here we have what? Pi sine of what? N pi. Plus what? Cosine of n pi over what? Over n. Then minus. Cosine of 0 is what? 1 over what? N. Are we together? Then for this case, we have to go and test. When n is equal to 1, what is sine of pi? Use your calculator. When n is equal to 1, it means 1 times pi, it is pi. Sine of pi is equal to what? 0. Okay? When n is equal to 2, 2 pi. 2 pi is 360. Sine of 360? 0. When n is equal to 3, 3 times 180? 120. 3 times 180. Thousand. 540. Sine of 540 degree? 0. So this one, according to the nature or according to the angle, so this one has 0 contribution. Are we together? So if that's the case, you say what? AN is equal to what? 1 over what? Pi n. Then we have what? Cosine of what? N pi of what? Over n. Minus what? 1 over n. Simply is equal to what? Cosine of n pi minus 1 over pi n square. Right? Right? So AN is equal to what, Emily? Cosine of n pi minus 1 over what? Over pi n square. As I told you that you should not underline, because that's not the final response. So that's the value of 40 of AN. So right, then we go for the next step. We are still solving the same question. Whenever you want to deal with. Okay, so now we are going for the 7th step. 7th step. So 7th step, let us find what? Bn, the third Fourier coefficient. Okay? So to find it, we have to recall its general formula from the Fourier series of the periodic function. So recall the formula of what? Bn. Class, tell me Bn is equal to what? FFX, NX what? Dx. Okay? Then now we are going to feed the given information. So Bn is equal to what? 1 over what? Over pi. Then what? We open the curly bracket. Then we integrate from what? From 0 to pi. Then x. Then sine of what? Nx dot dx plus what? Integral from what? Pi to what? To pi. Then what the function? 0 times what? Sine of what? Nx dot dx. Are we together? Yes. So from there we are going to have Bn is equal to what? 1 over pi. Integral from what? From 0 to pi. X sine of nx. Again, we have an integrand which is the product of the two different functions. This is the first function, which is polynomial, and this is the trigonometrical function. So we have to go for the next step. That the 8th step, we have to integrate it by using integration by what? By part. Right? So here it is equation 3. So then we go for the 8th step. So 8th step, we say that integrate what? Integrate equation 3 by using integration by parts. It's not about partialization. That's all about Laplace. Don't confuse partialization technique and integration by parts. So there's no need for you to recall the formula because you have already introduced the formula within your solution. Listen, and you have just numbered the equation that is equation 2, right? So simply you go straight forward. You have to go for the late because you'll be doing redundancy, repeating the same information. This is all about integration by parts that we have already discussed. So we are still solving the same question. Okay? So let u is equal to what? X. Let dv is equal to what? Sine of what? Nx do what? Dx. So any student who is not mentioning is writing. Then we need what? Derivative of what? Of u with respect to x. This is equal to 1. Then du is equal to what? Dx. So we have dv is equal to what? Sine of what? Nx do what? Dx. So we have to integrate both sides. Then I told you as an adult, this one and this one will cancel. V is equal to what? If integrated sine nx dx, what do you get? Negative cosine of what? Negative cosine of nx over n. So this is important information, important information, important information. Right? So next you have to substitute on the right hand side of equation 2. Then, if that's the case, you are looking for Bn is equal to what? 1 over pi. Then, open the curly bracket. Then, students, mention, you are writing. What is u? X. What is v? Negative cosine. Negative cosine of what? Mangoes. 0 to pi minus. Then we integrate from 0 to pi. What is v? Negative cosine of what? Of what? Then what? Then Bn is equal to what? 1 over pi. Take n out of the bracket. So you have to close. I have two students who are very good in writing. Jacksoni and the Faraji. So those students, I have to prepare a gift to give them because they don't listen, they just write. Okay, so then we have what? So we have open bracket, negative. So we have to substitute the limits for the first part or for the first term. So listen, and you have to be careful whenever that you have a negative sign in your function. So we are substituting, whenever we have x, we are going to replace x with pi. Okay? So here we are going to have what? Firstly, negative pi, then cosine of n pi. Are we together? Then minus. You see, Faraja was writing, so she's still thinking about n within the bracket, while we have taken n out of the bracket. Then we have what? So here, we're going to have negative 0 times what? Cosine of 0. Just like this. So negative says negative, positive. Integral from what? 0 to pi. Then you have what? Cosine of nx dx. Are we together? Richard, are you there? Bn. So Bn is what? 1 over pi n. Then we open the curly bracket. So we have what? Negative pi cosine of what? N pi. Minus what? 0. Okay? Plus what? What do you get if you integrate cosine of nx? Sine. Sine of what? Nx of what? Over n. From what? From 0 to what? To pi. Then we are looking for what? Bn. Bn is what? 1 over pi n. Then we open curly bracket. Then you have what? Negative pi. Cosine of what? N pi. Are we together? Plus. Sine of what? Plus sine of pi n. Over what? Over n. Right? Minus sine of 0 over n. Okay? Then Bn. Bn is equal to what? 1 over pi n. Okay? Then you have what? Negative pi cosine of n pi. Plus what? Sine of n pi over n minus what? 0 over n. Okay? So Bn, you can simplify at this point. When n is equal to 1, we have pi. Pi is 180 degrees. Cosine of 180 degrees, negative 1. When n is equal to 2, 2 pi, which is 360. Cosine of 360, positive 1. So it will never give you 0. Okay? Then you go. When n is equal to 1, sine of 180, 0. When n is equal to 2, sine of 360, 0. So for even and odd terms, this one will cancel. So this one will give us 0. 0 over n, and a number of 0 over n a number? 0. 0 over n a letter? 0 over n a letter? 0. So Bn is equal to what? 1 over pi n. Then you have what? Negative pi cosine of what? N pi. Are you together? So you can simplify. Pi and pi cancel. So simply say that this one negative, so you'll have negative cosine of n pi over what? Over what? Over n. So Bn is equal to what? Negative cosine n pi over what? Over n. So some students, whenever they see that they've been given a function which is x, which is odd, without taking considerations of the second subfunction, they use always to claim that, the function is odd. So if it's odd, an will be 0, ba naught will be 0. That's not correct for this case. We found them, and all the three Fourier coefficients are not equal to 0. So it depends to the question that you've been given. Are we together? Are we together? Is it clear? So this is still intermediate solution. We didn't reach the final solution. So now the next step will be going to find the first, second, and third terms of the series, and we obtain the Fourier series. That will be the end of our question. Is it interesting? Yes, that is engineering mathematics. Why it's not interesting? It's interesting because you chose yourself to study engineering. Did I give you any advice to study engineering? No. You decided yourself. Okay, so is that the case? We have, so let's just write the summary of the important information that we've been finding. We have a naught is equal to what? Pi over 4. An is equal to what? Cosine of n pi minus 1 over what? Pi n square. Then Bn is equal to what? Negative cosine of n pi over what? Over n. So you could see that all the three Fourier coefficients are non-zero or are not equal to 0. Okay? So you go for the next step is what? Step number what? 9. The 9th step. So the 9th step, we say that let us now all three Fourier coefficients are not equal to 0. Okay? So this one is not equal to 0, this one is not equal to 0, this one is not equal to 0. Are we together? So the 9th step, it depends. Once you have these two Fourier coefficients, you could find the first term, second term, and third term. Stop writing. So the 9th step, you can find the first term, second term, and third term of an, and the first term, second term, and third terms of what? Of bn. Then you write the general Fourier series. Or, alternatively, you can just go to this step. Recall the general formula of Fourier series. So, which state that what? F of x is equal to what? A naught plus sigma notation, n is equal to 1 to infinity. Then you have what? A n cosine of what? Nx plus what? Bn sine of what? Nx. Okay? So, you can write these are the Fourier series in terms of sigma notation. A naught is pi over 4 plus. Then you have what? Sigma notation when n is equal to 1 to n is equal to infinity. I said stop writing. So then we have what? An. What is an? An, it's cosine of n pi minus 1 over n over pi n square. Then you have what? Cosine of what? Nx plus. This is an, just like what you have here. This is an plus. So this is the point where we are. What is bn? Bn is negative what? Negative cosine of n pi over n and sine of 40 nx. So this is the Fourier series in terms of sigma notations, which we call it in shorthand. It's already a series, but it's a series which is summarized in terms of sigma notation. Are we together? I say stop writing. Then we can go, this is the 10th step. So the 10th step, we say that let us find the first Fourier, the first three Fourier terms. First three Fourier terms. So in the test, you have been asked to find something like this one, 3b1 plus b2. Nothing. I have told you. Simple. Because b1, b2 is when after you found the bn, then you substitute when n is equal to 1, n is equal to 2, n is equal to 3. But you told me that you were busy, so you couldn't give me the feedback of what. Okay, so find the first three Fourier terms. What do we mean? We mean that we have to find for n is equal to 1, for n is equal to 2, for n is equal to 3. You can find even 4 Fourier terms or 5 or 6. You are not limited. Right? But when you have at least 3 terms, you can write a series of terms. You have the first term, second term, and third term, and then plus, dash, 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 dash. Are we together? So we start that, we say when. So this one, we can call it, let's say equation 4. When n is equal to 1. So, when n is equal to 1. So it means that, for that case, you have a choice. Either you can find A1, A2, A3, A4, A1, A2, and A3, and B1, B2, B3. Then you substitute them in this term. Okay? So, when n is equal to 1, or you can just say this one, when n is equal to 1, or you can just do this way, that you have f of x. Stop writing, look. We have pi over 4, which does not change, plus, then we don't write this sigma notation. We are substituting when n is equal to 1. Okay? So when n is equal to 1, here we are going to have what? Cos of pi. Cos of pi is what? Use your calculator. Cos of pi, students? Negative 1. So you'll have negative 1 minus 1. Negative 2 over what? Over, then 1 square. 1, right? 1 times pi. Pi. So we'll have negative what? 2 over pi. Then when n is equal to 1, we'll have cos of what? I say stop writing. Cos of x. So look, so we'll have negative 2 for this term when n is equal to 1. Over what? Over pi. Okay? Okay? Then what? Cosine of what? X. Are we together? Next, we say that when n is equal to 1, cosine of pi. Negative 1 times negative. Positive 1 over 1. So 1 over 1? 1. Then what? Sin x. 1 times sin x? Sin x. So these are the two terms when n is equal to 1. Are we together, class? Richard, are you there? Very good. Plus, we are going for the next two terms when n is equal to 2. That's why you say from n is equal to 1 to infinity. Right? So when n is equal to 2, we substitute in this Fourier series. So when n is equal to 2, we have what? 2 pi. 2 pi is what? 360 degrees, right? Cosine of 360 degrees? Positive 1. Positive 1 minus 1? 0. 0 and then 2. 2 times 2? 2 times 2, 4. 4 times pi, 4 pi. 0 over 4 pi, 0. So 0 times cosine of 2. So you'll have 0 times cosine of 40 of 2x. Are we together? Eh? Are we together, Richard? Huh? Plus. Or whatever that we say minus. N is equal to 2. Cos of 2 pi. 1 times negative. Negative 1 over what? N is equal to 2. Negative 1 over 2, right? And then N is equal to 2. Sine of 40? 2x. So here you're going to have 40. Negative 1 over 2. Sine of 40? 2x. The advantage of finding the first, second terms by using the whole Fourier series is actually you cannot forget these two functions. If you find the terms by using A1 or by using this formula and this formula, you may forget to substitute n is equal to 1, n is equal to 2, n is equal to 3 in cosine of nx and sine of 40 nx. Are we together? Are we together? So then, so we are done with n is equal to 2. Okay? Next, we say what? Plus. When n is equal to what? 3. Cosine of 3 pi. Cosine of 3 pi. Negative? Negative 1. Negative 1 minus 1. Negative 2. Then 3 times 3 square. 9, right? So you'll have negative 2 over 9 pi. Right? Cosine of 40. So it is negative 2 over what? 9 pi. Cosine of 40, 3x. Are we together? Then next, when n is equal to 3, cosine of 3 pi. Negative 1, there is negative. Positive 1. So here we'll have plus. Right? So positive 1 over what? 1 over 3. Okay? Then what? Sine. When n is equal to 3, 3x. We have already 3 what? Terms. Why should you find the 3 terms for an and the bn? Because sometimes, in some cases, you can find, if you find only maybe the 2 terms, then you find the second term is 0. So you won't have a series at all. Because a series consists at least more than 2 terms. Are we together? So now we rewrite our function. F of x is equal to what? Pi over what? Pi over 4. Do we have any constant term? No. Pi is not constant. Here we have pi, but here we don't have pi. So we have what? Richard, minus. Minus what? 2 cosine of what? Of x. Over what? Over pi. Are we together? Then plus what? Plus sine of what? Sine x. Okay? 0 times cosine of 2x? 0. Minus what? Sine of 2x. Over what? Over 2. Okay? Then what? Minus 2. Cosine of what? 3x. Over what? Over 9 pi. Okay? Then plus what? Sine of 3x. Over what? Over 3. Plus what? You put 3 dots. So this is the Fourier series of the given function. Did you understand? Yes. Okay, so if you understood, I think that I have to leave the... Have you copied this or not? Yes, you have copied this one. So let me leave the homework. This is the end of our today's class. But let me leave the homework which will test your understanding. If you have any question, don't hesitate to ask. The online students, you have to ask your question in the comment section. So refer EIT final exam of 2016, question 1, Roman B. So the question says that if FFX, so I have also tried to EIT's concept, FFX negative 1 plus x negative pi less than x less than 0. Then 1 plus x 0 less than x less than pi. Then 2 pi no, this is all. With period of 2 pi, then find the Fourier series for FFX. So, my dear students, that is all about lecture 8. And that the homework that I have left for you, you have to make sure that you do, because when you manage to solve that composite function, then you'll be in a good position to answer different questions about what non-periodic function. So remember that I told you that the non-periodic function, the function here, listen, the function here might be either polynomial, or exponential, or trigonometrical, or logarithmic. Okay? So sometimes because of the limitations of time, we cannot maybe teach you the examples for each of that type of the function. But you have just to remember. So later on, when we get time, maybe we can solve questions when you have a polynomial, maybe we have exponential function. Later on, you solve. But the trick is still the same. Or if it is trigonometrical function, then we have to apply the constants of factor formula. Okay? So we can check later on, see if we'll get time to deal with other function. But fundamentally, this is polynomial functions, which is actual, most of them are non-periodic. Okay, so if that's the case for the online and even the local students, this is the end of lecture 8. I thank you very much. In case you have any question, don't hesitate to ask. In case you did not understand, don't hesitate yourself to watch this video and repeat and be serious, because I believe that this stuff are not difficult rather than your ability to understand. So see you. I invite you in the next lecture, which will be lecture 9, where I will be introducing the third topic of Fourier series, which we call the Fourier series of all the even function and the half range function. So see you in the next lecture. That's lecture 9.